Assalamu alaikum, dear students. I hope that everyone is doing well. We have to continue with Unit 5, Sets and Functions, and the topic for today is function or mapping. Let's have the introduction of the topic.
What is a function? In simple words, a function is a special relation. It produces new elements out of some given elements. Let's understand it in terms of sets. In mathematics, a function is a relation from set A to set B if every element in set A has one and only one image in set B. This means that every element in set A is mapped to some element in set B. Note that no element in set A should be left out. Yes, we need an example to understand it better. We know that a relation from set A to set B gives us ordered pairs of the form A, B. Now let's look at the two sets A and B. Set A has elements 2 and 4, and set B has elements 10 and 20. Let's look at an arrow diagram to represent the relation B is equal to 5A. This is how we can write it in the set builder form. We know that 2 times 5 is 10 and 4 times 5 is 20. Hence the two arrows like this. We see that both elements 2 and 4 are mapped. Also, each of the elements in set A has only one image in set B. 2 has an image in 10 and 4 has an image in 20. So we can say that every element in set A is mapped and has one and only one image in set B. We can say that this relation from set A to set B is a function. Now let's look at set A and B again. Set A has elements 2 and 4. Set B has elements 10 and 20. Now we look at the relation B is a multiple of A from set A to set B. This is how we can write it in the set builder form. And here's the arrow diagram for the relation. Both 10 and 20 are multiples of 2 and 20 is a multiple of 4. Would this relation qualify as a function? Look closely at element 2 in set A. It has not one but 2 images, 10 and 20 in set B. Element 4, however, has only one image. Since one of the elements has more than one image, we can say that this relation is not a function. Now let's introduce another element 9 to set A. So set A has elements 2, 4 and 9. Set B has elements 10 and 20. We want to know whether the relation B is equal to 5A from set A to set B is a function or not. Can you draw the arrow diagram for this relation first? Yes, this is how it will look. We can see that 2 is mapped to 10, 4 is mapped to 20, and 9 is not mapped to any element. So we can say that 9 has no image in set B. Although the elements 2 and 4 in set A have one and only one image in set B, every element in set A is not mapped. And hence we can say that this relation is not a function from set A to set B. Let's try out one last combination. Let us introduce element 35 to set B and remove element 9 from set A. So A has elements 2 and 4, set B has elements 10, 20 and 35. Is the relation B is equal to 5A from set A to B a function? What does the arrow diagram tell us? It says both elements 2 and 4 are mapped to only one element each, 10 and 20 respectively. No element in set A is left out. But there is something interesting we notice here. Element 35 in set B is not an image of any element in set A. Is this relation a function? Yes, this relation is a function. This is because every element in set B need not be an image of an element in set A. The only condition for the relation to be a function is that every element in set A has one and only one image in set B. These were some examples to identify if a relation can be a function. So we can say that every function is a relation, but a relation may or may not be a function.
Dear students, in the previous lessons, we learned about the Cartesian product. That Cartesian product is a set which contains all the possible relations between the elements of set A and B. Then we learned about binary relation. That binary relation is the subset of the Cartesian product. Or in other words, we can say that a specific relation picked up from the set of Cartesian product is known as binary relation. We have to extend the topic of binary relation and we have to introduce a new topic, that is function. Function is basically a special type of relation which relates the input with output. So for every input there is exactly one output. For instance, if y is a function of x, so for every value of x there is one output, one value of y. So we can say here that function is a relation, or a relation can be a function if every element in set A has one and only one image in set B. We can better understand this with the help of an example. Let's have set A with the elements 2 and 4 and set B has the elements 10 and 20. The relation between these two sets is that the second element in ordered pair is the 5 times of the first element in ordered pair. As 10 is 5 times of 2, 2 5s are 20. Similarly, 20 is 5 times of 4, as 4 5s are 20. So we can see here that every element of set A has only one image in set B, as 10 is the image of 2 and 20 is the image of 4. So this relation can be a function because every element in set A has one and only one image in set B. Let's have another case to understand the function better. We have the same set A and set B, but the relation is different here. The relation between these two sets is that the second element in ordered pair is the multiple of the first element in ordered pair. As we can see here that 10 is the multiple of 2, similarly 20 is also the multiple of 2. Moreover, 20 is the multiple of 4 as well. So here in this example, what we can observe that 2 has two images in set B. The one image is 10 and the other image is 20. So this type of relation cannot be a function because it does not fulfill the requirement of the a relation to be a function, which is that every element in set A must have only one image in set B. Let's have another case here to better understand the concept. Let's include one more element in set A, which is 9, and the relation between the both set is that the second element is 5 times of the first element in ordered pair. So we have the relation here that 10 is the image of 2, as 10 is the 5 times of 2. 20 is the image of 4. What we can observe here that one element in set A has no image in set B, or it is not mapped with any elements of set B. So this type of relation cannot be a function because the second condition for the function is that every element in set A must have an image in set B, but here element 9 is not mapped or has no image in set B. So this type of relation cannot be a function. Let's have one more example here to understand better that we have set A and set B, and here we have an element 10, 20 and 35 in set B. Now let's see that whether this relation can be a function or not. We have two conditions for a relation to a function here, to be a function here, that all the elements of the set A must have an image in set B, and the second condition is that every element of set A must have an image, and it must have only one image. So we can see here that 2 has only one image and 4 has only one image. Moreover, there is no any element in set A which is left out without any image. So this example is fulfilling both the conditions of a relation to be a function, so this is a function. However, we can see that one element in set B is not the image of any element of set A. But it doesn't matter because every element in set B need not to be an image of any element of set A. So we can conclude here that every type of a function, that function can be a relation. But all relation may or may not be a function because every relation may or may not fulfill the requirements of being a function. Let's have a further explanation of the topic that suppose A and B are two non-empty sets, then relation function A to B is called a function if it fulfills these three conditions. The first condition for a relation to be a function is that if domain of function is equal to A and range is subset of B. This line under this subset sign shows that range can be equal to B as well. So if you want to identify that whether a relation is a function or not, so if you find the domain of function, if it is equal to A and the range is subset or equal to B, then it can be termed as function. Moreover, the very condition for a function to be a relation is that x or the first element in ordered pair just appears one. It should not be in repetition. Or in other words, we can say that elements of set A must have one image in set B. As we can see in this example that every element of set A has only one image. As the image of 1 is P, the image of 2 is Q, and 3 is Q. Moreover, X only appears one time as 1 with P, 2 with Q, and 3 with Q. So no element is in repetition in ordered pairs. In addition, the third condition for a function is that all elements of set A must have an image in set B. We can see here that all elements of set A has an image in set B. However, it doesn't matter that every element in set B should be an image of elements of set A, as we can see here that R is not an image of any element of set A, so it is a function. Here this cannot be a function because 2 has two images in set B. 2 has the image P as well and 2 has the image Q as well, so this cannot be a function. Similarly, this cannot also be a function because here one element in first set or in set A is left without any image. Moreover, this cannot be a function because 3 is repeated twice. 3 has two images in set B, which is 4 and 5. We have here some more examples of function that this is a function because all the elements have image in set B. Moreover, no element is left out without any image. Similarly, this is also a function because every element has an image in set Y and no element is left out without an image. But this cannot be a function because element C has no image in the second set. Similarly, this cannot be a function because element of the first set is in repetition. A has two images, 1 and 2. So this is not a function. Here is an activity for you. You are going to think, then you are going to state that which of the given is function. So we can conclude here that the first one is a function because every element of first set or set X has an image in the second set and no element is left out. But this cannot be a function because 2 has double images. In addition, this can be a function because all the elements of set A has an image in set B and no element is left out. This is also a function because all the elements have an image in the second set and no element is left out. But this cannot be a function because the element 4 has two images in set B. Let's have further explanation of the topic here.
We know that a relation is a set of ordered pairs that satisfy a relationship. This was the Cartesian product of sets P and Q we'd seen previously. And this is set R dash. terms image, range, domain, and codomain. We know that the set R dash has three ordered pairs, 2, 10, 2, 20, and 4, 20. Here we can say that 10 is an image of 2, 20 is an image of 2, and 20 is an image of 4. We can say that every Q in set R dash is an image of its P. The set of P of all ordered pairs P, Q in set R dash is called the domain. Or we can say that the set of the first elements of all the ordered pairs in set R dash is called the domain. So we can say that the domain contains the elements 2 and 4. Now it would be very easy to guess what range means. The set of Q of all ordered pairs P, Q in set R dash is called the range. Or we can say that the second elements of all the ordered pairs in the relation R is called the range. The range contains the elements 10 and 20. So all the first elements form the domain and all the second elements form the range. What is the codomain here? The whole set Q is called the codomain of relation R. So the codomain here will contain the elements 10, 20 and 35. Easy, wasn't it? Now I want you to look at the range and the codomain and find a relation between them. What can we say? We could say that the range is a subset of the codomain. Here is an arrow diagram to learn what is domain, range, and codomain. So, this is the domain, this is the range, and this is the codomain for our relation R.
The concept of range can help us to understand the types of function. We have different types of the function, so let's go with them. The first function here is into function. A function f a to b is called an into function if at least one element in set B is not an image of some element of set A. That is, range of f is subset of B. We can better understand into function with the help of an example here. Let's have a function a where a is related with 1 is related with a, 2 is with a, 3 is with c, and 4 is with d. So we have a function here and we are supposed to identify the types of function here. So what into function states? Into function states that if at least one element in set B, at least means it can be one and it can be more than one. If at least one element is not an image of some element of set A, we can see here that we can see one element in set B which is not the image of any element of set A. Similarly, we can see here two elements B and A which are not the elements which are not the image of any element of set X or first set A. So these can be, or these are the examples of into function. In other words, we can understand or we can identify the into function if range of function is subset of B. Suppose this is a function and this is set B which has the elements A, B, C and D. If we want to find the range of the function, so the range is the second element which is A, C and D. So we can see that this is the subset of B. Range is subset of B. So this can be termed as into function if range is subset of B. We have another type of function here, one-to-one function. A function f a to b is called one-one function if all distinct elements of A has distinct images in B. One-one function states that every element is connected with only one element in set B, as 1 is with A, 2 is with B, 3 is with C, and 4 is with D. Similarly, red color with red shape, green color with green shape, blue color with blue shape, and yellow color with yellow shape. So this is known as one-one function. Next, we have into and one-one function. When into and one-one function is combined, so combinedly it is known as injective function. A function f a to b is called injective function if function f is 1, 1 and into. We can better understand this with the help of an example here. We can see that this is 1 function because every element is connected with just only one element in set B. Moreover, we can see that this is into as well because one element in set B is not the image of any element of set A. So 1 and into will combinedly make injective function. Similarly, this is also injective function because it is 1 and it is into. However, this is not an injective function. Why? Because it is not 1 as it is one to many. One has two images. B is the image of 1 as well and B is the image of 2 as well, so it is not 1 function, so hence it is not injective function. We have another type of function here which is named as onto function. A function f a to b is called an onto function if every element of set B is an image of at least one element of set A, that is range of f is equal to b. We can better understand this with the help of an example here, that for onto function every element of set set B must be an image of at least one element of set A. We can see here that in set B all the elements are the images of some elements of set A. X is the image of A, Y is the image of B, and at least here, so Y more than two elements can be. So Y can be the element of C as well, and Z can be the element of D. Z can be the image of D as well. So here no element in set B is left that it is not the image of any element of set A. Similarly, we cannot see here any element left which is not the image of any element of set X or first set. Same is the case here. So this is an onto function. The difference between into and onto function is that in into function there must be an image or an element in set B which is not the image of any element of set A, whereas onto function is opposite to it. In onto function there must not be any element in set B which is not the image of any elements of set A. Here we have bijective function. A function f a to b is called bijective function if function f is 1 and onto. If the function is 1 as well and it is onto as well, so combinedly that is known bijective. It is 1 and into, it is known an injective. It is if it is 1 and onto, it is bijective function. For example, we can see here that this is 1 because every element is connected with one and only one element. Moreover, it is onto as well because no element in set B is left is like this, that it is not an image of any element of set A. So this is bijective function. Here is an activity 2. You are going to identify the types of functions. So we can conclude here that this is 1 function and this is an into function as well because one element in set second set is not the image of any element of the first set. So 1 in into will make the injective function. This is into function because one element is not the image of any element of set A. However, this is an 1 as well and this is an onto as well, so combinedly it will be bijective function. This is into function, this can be also into function, and this is a bijective function. It can be because every element is means it's not bijective, it is onto function because no element in set B or say set Y is left or is not the image of any element of set X. Okay, here we are done with the explanation of the function, and this is all for today. Here is your homework. You are going to read page number 99, 100 and 101, so to revise the topic function or mapping. Stay blessed. This is all for today. Have a nice day.